상완이. This brings us to 10.7, similar triangles, on page 612, which is very similar to similar figures, and also a little bit similar to congruent triangles, but it's not exactly the same. So before I confuse yourself and myself, let's have a look. The good news is there's actual real life use for these similar triangles. Have a look at the following. You can actually measure the height of objects like a tree if you use your shadow, and that you can do because of similar triangles. You can also measure the width of a river, which you cannot reach on the other side, by making use of similar triangles. Even better than that, you got two methods to calculate the width of a river, which means you can measure two rivers at the same time using two different methods. How cool is maths? I'm not going to tell you how now. You're going to find out for yourself when you get to the problem solving questions of this 10.7. So let's have a look. This is very important. So all fun's finished. Now we do the very serious maths problems, which you need to understand, otherwise you're going to fail. The first thing that we need to know is that, like we had in congruent triangles, there are 4 tests that help us to establish if triangles are similar. So before we can use similar triangles, you need to know, are they similar? Now there's 4 tests, just like in congruency, but not exactly the same. So please pay attention to the following. The first one that we have is, for a similar triangle, is that the 3 pairs, which is angle, 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 which is not a condition of congruency, it's only a condition of similarity. So for 2 triangles to be similar, if I have 3 pairs of corresponding angles, they are equal. If only 2 pairs are given, like in the example that we see here, so even if we have it in this manner, you can see that there's only 2 angles. The third angle, according to the sum of angles of a triangle, these 2 triangles must be exactly the same, because both of them will be 180, take away 85, take away 60. So the moment I have 2 angles, guess what? We have similarity. The second one is side, side, side. So that is exactly the same as we had. So it's not though the same, but the corresponding sides are in the same ratio. So remember, similarity sounds like ratio. Okay, it doesn't, but remember, similarity is a ratio. So all 3 sides need to be on the same ratio. And this is what we indicate with this thing here. DE, so DE over AB is the same as EF over BC is the same as DF over AC. And all of them is 2. So it comes back to the thing called the factor ratio, right? Or the ratio factor, or I can't remember now, but we'll get back to that. Our next one is sus. So there's something sus here as well. 2 pairs of corresponding sides, and I can't, 2 pairs of corresponding sides are in the same ratio, and the included angle, so those words are very important, the included angle are equal. Okay, so this ratio, in this case there's only one angle, but ED over BA or BA is the same as DF over AC. So that ratio is 1.5, and we also have that the angle included are the same. The last one's RHS. So if they give us a pair of right angles, the hypotenuse, and these hypotenuse and another pair of corresponding sides are in the same ratio, then we have similarity. So that's how we test. So please, 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 pretty please, do not get confused with congruency and similarity. Let's move on. Let's go and have a look at the example. The examples is decide with reason why these pairs of triangles are similar. So you'll have to mention all of those. Are they similar? Well, we don't know. We can't just say they are. We need to find out what is this AD corresponds, I believe, to that. And we're also going to say that this one corresponds to that one. Now, to prove that, I'm going to say, or remember it's always the bigger one over the smaller one, I'm going to say FE over CB equals 10 over 5, and that equals 2. Now I'm going to use the red line, which is DE over AB is 4 over 2. So we can see that two ratios, so that is a side, and then it must be the included angle. Now is this the included angle that they give us? Is that the included angle? I am pretty sure it is, and they are the same, so I can say yes, they are similar, and the reason is, so angle E equals angle B, and that is the one in between, so therefore, and now let me just show you that. I haven't shown you this one before. I can say triangle EDF, and now look at not the congruency sign but the similarity sign. Looks like that, 3 straight lines down, and that is the same as, remember, corresponding sides will be B is corresponding to E, corresponding D is A, and corresponding to F is C. So we can say, well, the only thing that I need now is I need to say I have to put in a triangle BAC. What's the reason? It is sus. Okay, let's have a look at this one. First of all, what do they give me that is the same? So I'm going to mark them. I'm going to say this one is an angle which is the same as that one. Not that one. This one is the same as that one. And then the last one is going to be, what? Are they or are they not? Oh, if two angles are the same, the third angle must be the same. Doesn't matter what they say or what they do, because it will be 180 minus the others. Okay, so what I can say is I can say triangle I'm going to say triangle ABC is similar to triangle, same as A is D because it's red, same as B is E, and same as C is F. What's the reason I say so? Oh, it's not side, side, side. It is angle, angle, angle. Okay, let's look at the next example. Given that these pairs of triangles are similar, now this is very important. I'm going to highlight this in red. Given that they are similar, you don't have to prove anything, they are. Right, so take their word. They do lie sometimes, but most of the time you can take the word. They say they are similar, which means we can just use ratios. Now, I'm going to change a little of what I've done previously. I'm not going to calculate what is the scale factor. Right, I'm not going to calculate the scale factor. What I'm going to do is I'm going to use ratios, like we've done in chapter earlier on. Okay, so what I'm going to do is I'm going to say which sides are corresponding. This side correspond to that side. This side correspond to this side. And one more. This side correspond to that side. Now, what I need to do is I first have to look, do they give me any of the sides that are given? So both the blue sides are given. So that is the equation, that's the sides that I'm going to use every time. Okay, so what I'm going to do is when I calculate this, and this is different in the textbook, but it's going to help us later on because it's not always that easy to use the scale factor. So what I'm going to do is I'm going to say I want to find x, and I'm going to start with x on my ratio. I'm going to say x over, so I'm going to use x over the red side over the blue side, and I'm going to use the blue side because I have both those sides in both triangles. So I'm going to say x divided by 15 must be equal to, and similar to x is 4 over 5. Okay, so look carefully what I've done. I've said now that this is the x over 4, the two red lines, is similar to the two blue ones. So that one, and that one. So from the same triangle, so this is the large triangle, this is the smaller triangles, this is the large triangle, this is the small triangle. So say x over 15 equals 4 over 5. So the corresponding sides. Now, in algebra we have learned that to get rid of divide by 15, I'm going to multiply by 15. And I'm going to do this for you today in a different color. I'm going to say times 15 times 15. Now you can be lazy, right? It's your right nowadays. Everybody's got rights, so it's your right to say x equals, and you can simplify this with a calculator. 4 times 15 is 60. 60 divided by 5 equals 12. So x equals 12. The book used the scale factor. I don't care. I want you to use this because later on it does become easier. Now I want to find y. So what I'm going to do now is I'm going to start with y, and I'm going to say y. So the one that I want is always on the top left of my fractions. So I'm going to say y over. So what I'm going to do is I'm going to say y over the thing that I have. So the yellow over the blue. So y over 5 equals, and now I'm going to use yellow. I'm going to use yellow over blue for my big triangle. Okay, so my big triangle, yellow over blue, is 9 over 15. Let's use our colors. Right, so I said that I'm going to want to find the yellow one. Okay, so I said y, undo, I'll say y over 5, the yellow over the blue, and for what of the small triangle equals the yellow over the blue of the big triangle. And all I have to do is now I have to simplify. Okay, and I'm going to do it for you in green again. So I'm going to multiply by 5, and I'm going to multiply by 5 to get rid of 5. They cancel. 9 times 5, or you can say 5 goes itself once, and 5 goes in 15, 3. 9 divided by 3 is 3. Or, if you're lazy, use your calculator. You could say y equals 3. Okay. Easy. Let me quickly show you. No, I will not. Okay, so I want you to now go and do the following questions out of exercise 10G. So have fun doing those questions. My Southeast Asian food is ready, hint hint. So, la